Good morning. Today what we're going to talk about are how to prove that two triangles are congruent. So when I'm talking about proving the triangles are congruent, I actually don't need to know all of the sides and all of the angles like we looked at the other day. What I need is a combination of any three corresponding angles and sides. So I don't have to look at a triangle and another triangle and say this angle and this angle, this angle and this angle, and then mark them all congruent, all the sides. I actually don't need all this information in order to prove that triangles are congruent. Here, I would say, well, yeah, they're congruent based on all these tick marks. However, I don't need all that information. I can do it in a shorter way. So my first way to prove that triangles are congruent without having to say that all the angles and all the sides are congruent is by saying side, side, side. And we list this as SSS. However, we say side, side, side. When I look at side, 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 in order to prove that triangles are congruent, I have to see that all three sides are congruent to the three corresponding sides on the second triangle. What that means is exactly what your picture looks like. I notice that A to C is congruent to X to Z. So that's one set of sides. And then I can say A to B is congruent to X to Y. That's another set of sides. And then finally, I could say B to C is congruent to Y to Z, and that's my third set of sides. So when I do this, I can actually make a statement about these triangles being congruent given this information. I don't need to see that this is congruent to this is congruent to this. I don't need all that information when I have side, side, side. So therefore, I could say this triangle ABC is congruent to triangle XYZ with just this amount of information. So that's one of our first 5 ways to prove that triangles are congruent. Our second way would be called side, angle, side, and we're going to abbreviate this as SAS. We're not going to say SAS, but we're going to abbreviate it as side, angle, side. What this means is I have to have the included angle. So let me scroll down for you. I need to have 2 sides in the included angle are congruent to the corresponding 2 sides in the included angle on the second triangle. When I do this, what do I mean by included? I mean the angle that is between the 2 sides. So think about my fingers making a V. If this is my line and this is my line, it's got to be that one in the corner. So notice over here, I'm saying D to E is congruent to M to N. This is a side and this is a side. E is congruent to N. These show me angles are congruent. And then E to F is congruent to N to O. This is showing me the second side is congruent. So in this situation, this is all I need. I don't need to know that this side is congruent to this side. I have enough information given side, angle, side to prove that these whole triangle, everything, every little part about it is now congruent. I can write a congruent statement saying triangle DEF is congruent to triangle, MNO with just this amount of information. So I can prove this by saying side, angle, side. So remember, these tick marks show me that sides are congruent, and then these little arcs in the corner show me that angles are congruent. I have to be able to distinguish between those. So the important thing about side, angle, side is the angles between them. The angle cannot be out here and still prove side, angle, side. So we'll get to that. I'll show you that in example in a minute. My third way to prove that triangles are congruent is called angle, side, angle. And yeah, you probably can guess based on side, angle, side, that side is now included between the 2 angles. So I need to have 2 angles and the included side are congruent to the corresponding 2 angles in the included side on the other triangle or the second triangle. So when I look at this, I notice that J has a little arc in the corner. This tells me angle. I also notice that R has the same number of arcs. So J and R are in corresponding locations. This tells me that angle J is congruent to angle R. I can also see that I've got 1 tick mark here and 1 tick mark here. This tick mark tells me a side is congruent to another side. So J to K is congruent to R to S. And then finally, I notice that angle K is congruent to angle S, which means K is an angle and S is an angle. This proves to me that this side is squished between these two angles. This is the only side that I can use to prove side angles or angle side angle. I could not have this side over here on this triangle and ignore this one. This would not prove angle side angle. However, it would prove, before I move to that, I can now write a congruence statement. Knowing just this piece of information, just based on these markings, I can say JKL is congruent to RST. Therefore, then I could say, well, then L is congruent to T. I can now add that information in. However, I couldn't assume that before. Now I can, showing angle, side angle. Another way to do this, so number 4 would be angle, angle side. So notice how this picture looks different. I've got an angle at A and X are congruent. And I have another angle B and Y. Angle B is congruent to angle Y. And then this side out here, BC, is congruent to this side out here, Y to Z. This, I forgot my squiggly. This is actually called angle, angle side, or AAS. This has to be two angles in the non-included side. So remember side angle or angle side angle had to have the tick mark in between the angles. Now I don't want that. Now I want a side that's not between them. So not between. And it has to be congruent to the corresponding angle, angle, and side on this second triangle. Knowing just this piece of information, I could say triangle ABC is congruent to triangle XYZ. And finally, my last set of congruence would be hypotenuse leg. This is only true for right triangles, so circle this, star this. Super, super important. I only have a hypotenuse when I have a 90-degree angle. So remember, my hypotenuse is always directly across from my 90-degree angle. Notice these both have a hypotenuse and they both have one tick mark. This tells me G to H, which is my hypotenuse, is congruent to U to W. And then the only other piece of information I need is a leg. So a leg could be any line. It could be G to F and U to B, or it could be F to H and B to H. Knowing this, here's a leg, here's a leg. This proves that these two right triangles are congruent. That's all I need. I can say now GFH is congruent to UVW based on this information. So what I've done is shown you the 5 ways that you can prove triangles are congruent using a combination of angles and sides. So let's look at before I move on, there are things that do not prove. These are no's. Notice in this example, I have an angle here and an angle here is congruent to this angle and this angle is congruent to this angle. However, angle, angle, angle cannot prove congruence. For this reason, I could have a really big triangle and a really small triangle. These triangles are actually only similar. They are not congruent. I could have a small triangle and a big triangle with the same angle, so angle, angle, angle will never work. And then this other one. Notice I've got an angle here, and I've got a tick mark, and I've got a tick mark. I've got an angle here, and a tick mark, and a tick mark. These look congruent. However, I will say this one time. Hold on, pause for the announcement. Nope, nothing. However, this spells a bad word. You are never, 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 ever going to spell a bad word. So I'm going to write it one time and then I'm going to erase it. This never works. No, no, no. It doesn't matter if you write it this way. Still does not work. Cannot use that. So keep in mind, we don't say bad words in geometry, so I cannot show these are congruent. Now in these final problems, I want you to pause and see if you can figure out if any of these are congruent.